So, my name is Andy Davies. I work for a company called Lindorf, providing their payment solution. So if you've ever bought something online and you've got the option to pay with an invoice or with an installment, it's probably provided by us. I decided to do a serverless EventSourced Slack clone, partially because it's got lots of buzzwords in it, so I get people to come, and partially because I wanted to learn more about AWS. I use some parts of it very well, other parts of it I haven't really used, so mostly a learning exercise in how various areas work. Usually I've used EC2 and quite a lot of S3 usage. That's primarily what I use in AWS, and a little bit of Lambda usage. But I wanted to try and build something with a constraint of not having anything that wasn't serverless, despite running on servers. The naming annoys me, but hey. As you can guess, and I've mentioned it a lot, this is going to be AWS-based, but the principles of usage and some of the tooling will apply to other cloud providers. And my actual project I decided on was a chat app, because, you know, everyone likes Slack, and chat apps are simple, right? One of those problems that the more you look at it, the more not simple it can be, which obviously gets into the first hardest part of software development, which is analysis paralysis. I sat there for weeks going, now, do I do this or this or this? And then AWS comes in and goes, no, you can't do that. So, yeah, issues everywhere. So for the first audience interaction, who here has heard of Terraform? And hands up. Like 4 people? No? A few. So for those of you who haven't heard of it, it's a tool for scripting your cloud infrastructure. It works on AWS, obviously, and Azure, and other cloud providers, if there are any others. The only downside to Terraform is Kognito support is not there yet. We'll get into what Kognito is and why that's annoying later, but that's its only drawback that I have. If you want really thorough, in-depth talks onto how to use Terraform, I will have some examples, but there are a lot of great talks by Paul Stack and James Nugent you can go and look at online from previous NDCs that are great. That's how I picked it up. Yeah, so not Kognito. So this is what a Terraform file can look like. This is our variables file, so we put common information in here. In this case, we've got which AWS region we want to use by default, a name of a bucket that we're going to use. Crowbar, incidentally, is the name of my app because Lambda's Crowbar Half-Life, hence the stealing of the Half-Life 2 logo. And the final interesting part on this one is the data attribute at the bottom. This will fetch your Amazon account ID when it is called, so that you don't have to hard-code that number into your Terraform file anywhere, which I have been doing for quite a long time, and every time I've had to hard-code the number, I've not liked it, because everything else, like your actual credentials, are stored on your machine, so they don't enter your source control. But here's an account ID in your source control, and I don't like that. So after I found out how to use this AWS caller identity, that problem goes away. To actually set up a resource in AWS with Terraform is fairly simple. This looks like JSON. It's HashiCorp's configuration language, which is a superset of JSON, I think. I think they support, there's some relation with JSON anyway. You don't have to put commas in and semicolons. So this resource controls a bucket. It gives it a name and makes it publicly readable. Nice and simple. Unfortunately, not everything is simple. For instance, this is how you create an IAM policy. This particular policy is what I use for all my lambdas, so that when they're executed by when they're executing, they have access to various other resources, such as CloudWatch. If you give them access to CloudWatch, whenever you do a console log statement in a lambda, it'll appear in CloudWatch. This makes debugging much easier, and once you find out that that's the permission you've been missing, which took me a long time, then everything gets a lot easier. No searching constantly. Everyone's going, oh, all your logs will just appear in CloudWatch, and they don't if you haven't got that permission. But there's nowhere saying that the reason they haven't appeared in CloudWatch is because you're missing a permission. The template file mentioned at the top of this is because policies in AWS parlance are written in JSON files. This is the same JSON that you access through the UI. The only difference here is I'm using a replacement field so that I can put my bucket name in without having to hard code it in multiple places. So that's a brief overview of how you use Terraform. We'll have some more examples for the various areas of AWS as we go through. So on to my fantastic UI skills, which are non-existent. This is the UI for my chat app. It's written using React, Redux, and uses Bootstrap and Bootstrap Material UI because someone else has worked out how to make pretty UIs and I don't have to, because I normally do back-end engineering rather than front-end stuff, as this UI shows. All I'm allowing my users to do for this is create channels, send messages, and that's pretty much it. But despite only having a few functions, we hit a lot of different areas of AWS which I've never used before. So to host a website in S3, Terraform again. So as before, we have an S3 bucket set up. The only difference this time, hopefully this will work. There we are. And thanks Simon Brown for this pointer. The only difference here is we've got a policy of public read and a website configuration set up. This means that your bucket gets a name which is unique to the whole of, or has to be unique within an entire AWS region. So you can't just create a bucket called admin because someone else has probably got a static website called admin already. So if I wanted to call my bucket crowbar, the likelihood is, well, when I tried applying it once, at the time someone had a public website called crowbar already. So that was annoying. And I don't think it was me in the end. I think it was actually someone else. By using S3 for our website, we get a highly available front end. S3 is very scalable and almost never goes down. And we also end up with a slight limit of routing has to be hash-based. You can't use URL routing in an S3 bucket because they have to actually be documents. It becomes a path segment in the bucket name. Which means you have to set up Redux and React Router with hash routing and get all the right versions, which is a pain in, well, it took me weeks to get it right. And if I upload when I upload the code for this, if I decide not to squash my git commit history, you will see how long it took me to get routing working and how many times I had to go back to it when it turned out it wasn't working, but I thought it was. So yeah, out of everything, the hardest two parts are setting up IAM permissions and raging at React. But after that, everything gets easy. This is our policy for the S3 bucket. Pretty much the same as before, except we're allowing anyone to read this object, and they can only ever fetch documents in the bucket. We don't want anyone to be able to post a replacement index HTML page to our website, because that would cause bad things to happen. The actual architecture of this system comes down to a set of commands that you issue from your UI. Registering a user, creating a channel, joining, sending messages, leaving channels. This is why I thought it was a simple problem to start with, because it's just a couple of messages. I mean, you can just run some projections off that and job done. And it doesn't quite work out that simple. The first point is, do you model this as one aggregate that has all of these messages coming into it? Or do you model it as multiple? So, say a user aggregate and a channel aggregate. And part of that comes down to the decision of how you want to treat a channel. So, I had the option early on of, do you send a message to a channel, Or do you send a message and say this message goes to these channels? So more like a Twitter hashtagging. You could send a message and say, hash general, hash, I don't know, project 1. And that changes your design quite fundamentally up front. In the end, I decided as I'm building a Slack clone, I should probably send messages to a channel rather than building Twitter in Slack, which would be an interesting problem to start with anyway. So initially, I came up with the idea of these two separate aggregates, one for users, one for channels. The downside I realized is that both aggregates care about some of the same messages, which might be fine if everything works well. But what happens if you have a user and you say, I'm going to create a channel? And the user goes, right, that's fine. You've created the channel. I care about this, so I've written it to this store, and I've said that you've done it, and that's great. But the channel aggregate receives the command saying create a channel and goes, there's already a channel called this. You can't do it. Now you've got two aggregates in different states. I wasn't quite sure how to solve this, but wrote out my architecture anyway, looking like this. The first block, which is the yellow, is an API gateway. So this is Amazon's provider of a RESTful or HTTP API, and you can hook it up to Lambda and all other kinds of services, and you get, again, a highly available API that just scales. So when a command comes into this, we store it in a command store, dispatch it to all of our aggregates. If they decide to do something with that particular command, they'll emit some events. Events go into their own event stores, and projections are triggered off, which are AWS Lambdas, and write us some JSON views. So I'm using S3 for my views because then I can just leave them as public or authenticated, so valid logged in users are the only people that can see them, and we can just pull them straight into the UI itself. This makes views almost free because JSON objects are fairly small and highly available again, so the costing of fetching a JSON object from S3 is minimal. So I don't have to pipe it through API gateway and pay an API cost or through anything else. The downside to this, I realized, is that it's fairly complicated for a first implementation detail or implementation. And I have that problem with the aggregates not necessarily being in the same state. So if we look at how you might implement an aggregate in C#. By the way, has anyone done event sourcing in C# before? Okay, a few. And CQRS, like the buzzword, done it? Not done it, right. So in the case of this, we have a public method called join, pass in a user, we'll validate that that's a valid thing to happen, create our event, and then call this apply method. Apply just stores the events in memory, so when you call save on the aggregate, we write them to the event store. The handle method beneath gets called by the apply method, so actually does your state change. And that is also called when you're reloading your aggregate. So if you had multiple events to reload, you'd create a blank object and just say, apply all of these events in order, and you get back a fully hydrated aggregate. We also have projections, so aggregates can only ever be loaded by their primary ID, which in our case is a GUID. But quite often we want to know summary information about aggregates, like what is a list of all the channels available, who are all the users in my system. So we have an asynchronous projection. This sits outside of the aggregate, and when an event it comes through that it cares about comes through, in this case user joined channel and channel created, it does something and writes it to a view. I've missed out a lot of the error handling type code and actual writing to views because I'm just not interested in the structure for the time being. This is also using another view because our user joined channel event only contains a user ID and the channel ID. We already know the channel because it's us, but the user ID, we want to look up the current name of the user. So we're introducing a coupling between two views here. Rather than the name of the user at the time they sent the message, we're showing the name of the user as it stands now. This is great because you don't want someone to be able to log into your chat system under one name, say something really mean, and then change their name. And it would now show up as two different people saying things. In the background, they'd still be tied to the same user ID, but because it has the name different, you could potentially hurt people's feelings by pretending to be someone else. Temporal coupling like this does have issues, but for the time being, this is an acceptable trade-off for me because I want to show the current user. So if we take our aggregate and our projection, we just crush them up a bit so they fit on screen. It looks better on my monitor. Yeah, so no, they fit on screen, but we can split this in that this works fine for a completely server-side application. But we could split it so that on the client side, our JavaScript will create a command, validate that the command's useful, and dispatch it. Internally, the dispatch method is just calling one of these API gateways in AWS. On the server side, we only need to handle that we've received the command. So we take the command that appeared, store it somewhere, and trigger our aggregates. And then asynchronously, the aggregates run off creating our views and projections. Now you might notice I'm using JavaScript on the server side as well as on the client side. This is not in a particular love for Node.js. I have a love-hate relationship with JavaScript. It's great and it's terrible. The reason I'm using it on the server side is because of response times. I've found that a C# Lambda doesn't have a consistent response time when you invoke it from an API, or maybe when you invoke it at all. So this particular, the middle method for writing the command, takes about 200 milliseconds for the JavaScript version to run. When I implemented the same thing in C#, the second run of it took 800 milliseconds, as did the third and the fourth run. The first run took 15 seconds. And as you put a timeout setting on each Lambda, and normally I have it at about 3 seconds because that's a reasonably long time for a web request, if your first Lambda doesn't finish, then none of the subsequent ones will finish because each one is trying to, I guess, do some compilation in the background or deploying the image around AWS's infrastructure. But for whatever reason, C# as a response handler for a web API in AWS is not a good idea at the moment. I guess as it's new, there'll be improvements to it. If you were doing something that's computationally bound, longer running Lambdas where you've got a timeout of, well, the maximum's 300 seconds, I think. So if you have something that's taking a few minutes and computation bound, then sure, a C# version will be fine. But for something that you want low latency, quick responses, stick with the JavaScript. And you can still write tests in JavaScript, so hopefully it'll work. So our actual aggregate, when implemented in JavaScript on the server side, looks like this. The join channel method at the top is what gets called by the command. And I realized that I don't actually have any logic as such need to be done with my commands. If I get a user join channel command come through, if they're already in the channel, that's fine. It's an idempotent update. We can just keep adding the users to the channel, and if they're already in there, we're not going to do anything. And if they aren't in there, we'll just add them. And then I looked at the sending of message, and was just, well, each message has a unique identifier on it. So if we get the same message twice, we'll just not do anything with it. Idempotent again. So why bother? Our command roughly looks like this. We have a timestamp. We have an event ID, which is generated for each message that comes into the system. We have a type, and in this case, we have a user ID and a channel ID. So this is joining a channel. The event that comes out at the end of this looks like this, which is identical, apart from the fact that the event has gone from a command, join the channel, to a past tense event. A user did join the channel. Now, as I don't have any logic that would ever say block a user from joining a channel or from sending a message, it's assumed if you're signed up for my application, you're allowed to send messages. Why bother with the aggregates in the tool in the first place? Why not just use projections for everything? So we can simplify our architecture down to this. In this case, we just dispatch the events from the client side rather than commands, store them somewhere, trigger projections. Nice and simple. Good first product. If we need the commands and the aggregates, and we decide later on that there is logic we want to do for users joining channels, maybe you want to prevent people from putting swear words in their messages, that kind of thing, then we might need the aggregates. At which point, we've got all of the events stored, and as the events were almost identical to commands, we can just replay them into a command store, just changing them back into commands, and then run the whole system again, and you should end up with the same state. So we've got I wouldn't want to say future-proof architecture, but we've at least got a planned upgrade path. Now, the actual event storage is one of the first places that I hit problems with AWS. This is effectively what our eventing looks like. We have producers, which is in our case the web API, which is emitting events. And then we have two consumers, or as many as we want, which are our aggregates or our projections. Producers produce events, consumers read them off as quickly as they can to create your views, which is an ideal use case for Kafka. Has anyone here used Kafka before? Heard of? Okay. That's the same people sticking their hands up for each question. I'm not giving prizes for saying yes to things, by the way. So Kafka is log storage, or it's a distributed log storage. So we can use that as our event log. We have one event is a log line or log entry, and we can use that for all of our storage, and we can keep all of our data there. The downside to this is AWS doesn't offer Kafka as a service. It does, however, offer Kinesis. Kinesis is very, very similar to Kafka, at least its streaming. Kinesis streams are very similar to Kafka. The problem with it is that we want to use Kafka as our actual log storage for forever. And Kinesis has a limit of 7 days as an entry can live in it. So we can't use it as permanent storage. So for a demo, I could use Kinesis because I don't foresee a demo going on for longer than 2 weeks. I mean, I'm time boxed to an hour as it is, so I could demo it and be like, look, it works fine. And as long as you didn't check it back in 2 weeks, it would look fine. So I don't really want to use Kinesis. I could use Kafka, but I'd have to host it myself in AWS, in EC2, or I could host it with Docker containers. Docker is provided as a service by AWS, so hosting a Docker container in AWS is technically serverless, I guess. It's a bit of a cop-out, though. So I decided to try and not to use that, because I don't want to break my serverless constraint on the first issue I come to. So instead I thought, oh, well, Amazon's got many other ways of storing data. S3 would be ideal if it had an append mode. You can only read or write a file in S3. You can't append to it. You have to read it, add a line, write it back, and hope that no one else has written it back in the meantime. So if two users send messages at the same time, I could lose data. Or I could use their update mechanics to prevent that, but I'd then end up with two lambdas firing around after each other, trying not to overwrite, and then I'd end up with a deadlock. So I can't use S3. I could use their relational database service, store them in Postgres, which is the best database, so that was a very appealing way of storing it. But I've used Postgres before, so let's store it in something different. So I decided to store it in Dynamo. Dynamo is a document store offered by AWS. It's very easy to use. Has some interesting constraints, which I'll show you in a minute. The actual setup for a document database, it's very simple. Again, it's using Terraform. The interesting parts of this are the write capacity and read capacity. So write capacity is number of 1 kilobyte writes per second you want to do, and it's rounded up to the nearest kilobyte. So if you've got a 512 byte event, then it'll be rounded up to a kilobyte and count as 1. But as I'm storing 2 keys specifically, the actual hash key, the unique identifier, and a range, I actually use 2 capacities per write, one for the event and one for the index. So in this case, I can write 2.5 messages a second, which when I'm demoing this app is fine because there's generally only me on it. So as long as I don't type really quickly, it's fine. And if anyone's seen me type, you'll know that typing quickly means making mistakes and then deleting things, so that's fine. Because this is a document store, we can store anything in our events. We can just chuck them straight into the Dynamo table and retrieve them as is, or we can query them by event ID, and I've also defined the timestamp. So if I've got a projection that says, I want to know about all the events that happened between these 2 dates, I can pull them back by this. This is also how I'm implementing the ability to resume processing from the last event you store, because if we have the GUID of the previous event, we can look up its timestamp and just say, get me everything after the timestamp. Now, the limit of DynamoDB is that this is my channel created event. As before, timestamp, event ID, type, boring, user ID and channel ID. Then we have the channel name and an optional channel description attribute. If you try and insert this event into Dynamo, it will fail with a weird error message. I can't remember what the error message is off the top of my head. But this one will work, because DynamoDB doesn't let you store empty string values. Null is fine, empty strings not fine. Which is the opposite way around to what I was expecting. Research on the AWS forums indicates that this is by design, for reasons, and a lot of people who disagree with these reasons. And Amazon don't seem to want to fix this. So the suggested workaround for them is to use a value in your string which will signify that the string is empty. So I guess you'd generate a GUID at the beginning of your app and just say, whenever I see this GUID, it's an empty string because that's unique and hopefully there won't be another one. In my case, I just check if my text box is empty and write null to the value instead. That really annoys me because it really violates the principle of least surprise in an API. Why would this fail? After we've moved on past that, so as long as you don't try and store nulls, it's fine. So now we've got a way of storing our events. We now need a way to actually create events and put them into Dynamo. So here is our setup for an API gateway in AWS. The top block just says that we want an API and gives it a description. And then we have an API gateway resource, which is a path part. So if you want to have events/channel, you'd have 2 resources, one called events, one called channel, and just say that the channel is the child of events. So you can create multiple hierarchies of URLs. The downside of this is how much typing you have to do for it. If you've ever used a Lambda library called Claudia.js, they get around this by just registering the root URL and then handling routing internally themselves. So everything comes into one handler, and then they do routing and dispatch it to your own functions. We've also got a post method set up on the events, because that's all I care about. I don't want people to be able to get anything from my API. You just need to be able to push events to it. All the reads come from our views. And you'll note on my post event, where my cursor's gone, there it is. We have this lovely authorization equals none. This means anyone can write to my event API. As long as they put it in the right structure and don't put a null key in it, it'll be fine. Sorry, an empty string key. But that's only there because Terraform doesn't support Kognito yet. So to put validation on our API, we have to manually click around in the UI or use the AWS CLI to write a a Kognito authorizer for it. Yeah, and the last block just says that when this post method is run, we will take the data from it and post it to the Lambda function that we want to act as our handler. You'll note that the word post appears twice on here. This is the API's method, so you could have post, get, put, options, that kind of thing. The integration method, if you're calling a Lambda, has to be post. When I first was doing this, I had get in both places and was again getting strange error messages because it was trying to do a get request to a Lambda, which is not a valid thing to do. So yeah, that has to say post for the type of AWS proxy. Most of this code is taken off the Terraform documentation pages. They're very complete, and quite a few of their developers are very responsive on Twitter if you have questions. I harass them a lot. So the actual handler we're going to run when a method, or when this API is called, looks like this. The AWS event comes in. We use the object assign method to force in a timestamp that we control, because I don't want to rely on the user's computer's clock being right. And we will supply an event ID if there's not already one in the event. If I was actually doing this in production, I'm not sure if I'd treat event IDs like this. I might force them to have my event ID. The reason I do it this way around is because if I specify the event ID on the client side, for debugging purposes, I can trace it all the way through. I can see in my logs from the client where the event was generated, and then I can see into the AWS CloudWatch logs to see what went wrong, why it wasn't stored, where there was an empty string in it, which is usually my problem. So once we've hydrated our event with a few more properties, we write it to storage, trigger projections, and send OK to the user. Because we're using React, we automatically stick the result of them typing their message straight on screen. And I put a little indicator next to it to show that, it's probably there. And then once it is confirmed by AWS and it's appeared in the view, then the UI changes to reflect. You'll note here we're not assigning a sequence ID or anything to our events, because I didn't want any kind of blocking resource to say, this is the next event. If 10 people write it once or 1,000 people use my application, which seems unlikely, I don't want to cause any kind of blocking. We could get around this using Postgres. So again, if you decided that you want to have that many users and you need a sequential ID, then changing the data store to Postgres is probably a good idea. In fact, if I was doing this for real in the future, I'd probably use Postgres instead of Dynamo, because Postgres is the best database in the world. I don't get paid to say that, by the way. I just think it is. Actually invoking another Lambda, there is a lot of conflicting advice about this online. A lot of people say you should use the notification service with a Lambda hooked up to the notification service, and you send a notification to the notification service, and then that invokes the Lambda, and then that does the work. When you can just invoke the Lambda and not care about the callback. So that's what I do. I've missed out a lot of error handling from these, by the way. When I upload the code, you'll see that there's probably another 50% worth of error handling in this stuff, rather than actual business code. So in our case here, we are just invoking another Lambda called crowbar projections, and that itself looks like this. I have a function for each projection. Given an event, each projection runs it, and then the update view method here is just a wrap around S3, so I can test that my projections work without having to rely on AWS infrastructure. The downside to the way I've written this is that all my projections run inside one Lambda. So if you have one really badly performing projection, all of the others are going to be slow as well. This is fine for my first product, or my first deployment, because I'm only projecting users and channels. There's not that much information to slow things down. Again, in the future, when you start having more users, you can then upgrade your architecture to have each projection running in its own Lambda. This is one of the main tenets of deploying the simplest thing you need. Don't over-architect from the beginning, because well, the final architecture slide that I showed, I wouldn't want to start with that because there's too many moving parts that I will get wrong and tear out what hair I have left. An actual projection looks like this. So we just have an object of handlers. So channel created, user joins channel. All they do is they work in an immutable manner, so they return a new version of the view, updated with whatever the projection does, and return it in this. Where's it gone? So we just return an object back. This means that I can test each handler by just running the callback on a set known view, and in the main production code, we're running this update view function, which is actually reading from S3, applying the projection, checking that S3 has not been updated when writing it back. So this means our architecture looks like this. You'll note we're not actually using the event storage for anything in particular yet. It's just there for future usage when we want to make our architecture more fancy. This works. We have a statically hosted website, we call a web API, we store events, we trigger projections, and we read views from S3. There are problems with the actual projections, which we'll go into later, but if you're just one or two users in a chat room, you're not going to notice them. The second you start having more than a few users, they start becoming more evident. But the part I want to talk about next, which I've alluded to a few times, is Kognito. Kognito is a service by Amazon for providing authorization and authentication. It's an implementation of OpenID Connect and is very easy to use. There are a lot of examples, and on AWS's GitHub page, they have an entire repository dedicated to how to use it from JavaScript. A brief summary of how to use it for JavaScript looks like this. This is signing up of a user. The important part is this function. So in our case, we're generating a GUID as our user ID. I'm just putting the user's email address in as an attribute. The reason we do this is because, well, we could use their email address as the ID. The ID is immutable. Once you've written it, you can't change it. So if a user wants to change their email address in the future, they wouldn't be able to log in as that account anymore. So what we do instead is use a GUID as their user ID, email address as an attribute, and in the Kognito setup, you say that you want to allow login from that attribute. So I've allowed login from email address. This is very straightforward for signing up. Login is marginally more complicated. We take their username and password, email address in this case, set up our user pool, and then authenticate the user. Assuming things work correctly, I dispatch the user to the rest of the React system so that it now knows of the user, and resolve the promise. The downside I've had to this, the thing that I really was not comfortable with Kognito about, was this setup of the user pool. Because on my client side, I now have a user pool ID and a client ID. And as my client is JavaScript, anyone can read these. And that doesn't seem very secure to me. I don't want to give out any kind of AWS credentials anywhere. But searching again on the AWS forums reveals someone from Amazon saying that these two IDs can only be used to call unauthenticated APIs. So signing up, authenticating, forgot password. So there's no malicious activity that they can do with just these two IDs. That implies there is malicious activity they could do with those IDs and something else, and I don't know what the something else is. So apparently this is fine, so I just leave it on the client side, and this is only a demo app, so it's not going to hit production. If you really wanted to hide them, I think you could probably put your user pool usage inside a Lambda function in API gateway and do it like that, I guess. I'd need someone who actually knows AWS security to come and tell me if I'm doing this right or wrong. But works on my machine. And anyone else's, possibly. Now that we have authentication and have manually added it to our API, we also need to know about users that sign up. Now, when a user signs up, we have two stages to that. They enter their email address, they get a link in their email or a code in their email which says, go back to the web application, type this code in to prove that it's your email address. Basic email address confirmation. Which means I don't consider a user fully registered until they've approved their email address. So I don't want to dispatch my user registered event straight away. Like when they hit, my email address is this and my password is whatever, submit. I don't want to send a user registered event at that time because they might not ever follow through. That might not be their email address or they've made a typo. So the obvious solution and bad one, which you shouldn't do, is just to wait for a time. Just say 10 minutes after they've signed up, check to see if they've confirmed. If they have, great, successful user. This wouldn't be a good way of doing it for many obvious reasons. But, if that was the only way of doing it, luckily, Kognito supports triggers. Lots of AWS services support triggering, so we can put our own lambdas into the processes and either replace parts of a process or customize it. In the case of Kognito, one of them is the post-confirmation trigger. This is after the user has confirmed that the email address is actually theirs, run a lambda. There are also ones for pre-authentication and post-authentication, which would make for writing interesting projections of a user attempted login and then a failed or a successful login. You could then write a projection that would say, look for users who have got a high number of attempts at logging in, and we might have someone who's trying to brute force their way in through a user account. So we can put that kind of eventing data into our event stream as well. The actual handler for one of these looks remarkably similar to the API handler. The only difference is we're controlling the whole event ourselves. We grab the user attributes that come through. So in our case, we're only after the email and the sub, which is the unique identifier for that account. And we write it to our event stream and trigger all of our projections again. Sorry, nice and straightforward, that one. That one caused me a lot less hassle than the API gateway one. API gateway is also fairly picky on the response JSON you give it. If it doesn't have a body property, it fails. If it doesn't have a header property, it fails. But it only gives you a 500 error and just something like invalid JSON. And you look at it going, well, what's invalid JSON? Everything looks fine to me. It's valid JSON, it's just not semantically valid. Yeah. So as I've alluded to a few times in this, scalability becomes a problem with this architecture. So while the Kognito side of things, and the API gateway, and the website, and the first Lambda are scalable, the projection side of things is scalable in that they'll run, and you can have many of them running, but you might lose data. Parallel updates to S3, you can use what the word for it is, like a last write time. So when you write to S3, you can say, if the last write time is different from when I read it, fail the update. But if you've now got 2 or 3 or 10 or 20 lambdas all doing the same thing, you have 20 lambdas going, oh, that failed, I'll try it again. Oh, that failed, I'll try it. And you've got 20 of them and more messages coming in. You're just going to end up with a massive pile of deadlocks. And if you don't have a timeout on your lambdas, or you have a large timeout, you'll end up with quite a large AWS bill because a 300 millisecond or 300 second lambda running for forever, or as many of them as you can have, is going to cause problems. Luckily, AWS supports a lot more services that we can use to negate a lot of these problems. The simplest way to do this is just to stick the simple notification service and simple queuing service in between the two lambdas. The notification service literally distributes notifications to as many queues as it's got attached. In our case, we've only got one queue. But in the future, if we want to put our projections in separate lambdas rather than having them all running in one, we could have a queue per projection. Now each projection doesn't impact the running of any other projections. We can also use this queue for when we want to reload events. So if we come up with a new projection, we say, right, we want an all users who've posted in these channels in the last 10 days projection. We never thought we wanted this before, but now we do. We can just grab all of the information out of the event store and push it straight into either a specific queue for one projection, or we can push it into SNS and have all of our projections rerun. So if we want to rebuild our data model, that's how we do it. Event store, SQS, job done. We can also use this to make our application more flexible and support plugins, because everyone wants to write plugins. One of the initial plugins I wanted to write for this, like before I'd even written the application, was I wanted to write an IRC plugin, because I wanted to be able to interact with this as if it was IRC, because Slack is IRC with a really heavy, slow client. Why we don't still use IRC, I don't know. I mean, you can write a chatbot for IRC, so why use Slack? I mean, it looks pretty. But to write plugins, I'd put each one in a separate queue. We really don't want a bad plugin with a bad projection to slow down the running of the rest of our application. We also gain, because we've got this queue in place, when we deploy a plugin to our application, we can have a tick box that says, yes, I want all of the events for all history to come through my plugin, please. Hopefully that will not be ticked very often, because I would imagine that would create quite a large queue after a long time. But if that's what a plugin author wants, they have the ability to have that. Using lambdas for our plugins also gains us a couple of interesting use cases. We can either provide a pre-baked lambda that will run another JavaScript function, which might be like write to a view, and we can handle the fact that it writes to S3 or does something in the background. We just say, here, here's some data, do what you want, and we'll deal with the storage of this. But we could also provide a lambda that automatically invokes an HTTP endpoint. Or you could just, rather than using a lambda at all, have the ARN for a lambda, the full resource name, which, as we saw in the Terraform setup, is the gigantic string of text that says where a lambda is and where you should post to. But if we let a user specify their own AWS account lambda, we can invoke that from our queue. Now they can do whatever they want, however they want in their own AWS account, and it's not going to cost us a cent, which is great, because why should we pay for someone else's plugins to run? So if they get the full usage of AWS, they could do machine learning or some kind of AI on the people's chat messages, and it wouldn't cost us anything. Data retention might become an issue, depending on where your jurisdiction is. I mean, you wouldn't want to just hand messages out to anyone, so there is an interesting issue there, but it does provide a way of having a nice cut-off between this is the core systems account, and then we can have a different account for plugins or a different account per plugin. As I mentioned, wanting to write an IRC plugin, I'm not convinced I could write it in a serverless manner, because I think you need a persistent connection. I had a brief look through the two RFCs that cover implementing IRC. But there's also a lot of documentation saying these are the two RFCs that define it, and no server implements these. They do this slightly differently. And I thought, this is enough of a problem as it is to write without having to try and write IRC as well. Maybe later. If someone wants to send a pull request for an IRC client or server. So, a little wrap up of my experiences so far. I have learnt loads about the extra AWS functionality, mostly around Kognito. I want to now use Kognito for other things, like possibly server-to-server authentication, because it can support that too. I've learnt loads more about Terraform, because, like I said, as I normally only use EC2 and S3 and a tiny bit of Lambda, I've now learned about configuring API gateways and how painful configuring IAM is, no matter how you're doing it. But if it's in Terraform, at least you can version control it, and then when something stops working, you at least now have version history of why it stopped working. The trade-offs of making a serverless architecture. Yes, it is possible. Would I actually implement something completely serverless? Maybe. It's an interesting trade-off to make. It definitely makes you think about problems in a different way. But in the end, I'd still rather have stored everything in Kafka. Or had Kinesis with infinite storage. But the other part of the serverless trade-off, which this hasn't really touched on at all, is cost. Now, while I think you should always pick the right tool for the job, there is a little asterisk there on the end of that, which says the right tool for the job within budget. Just because something is available as serverless, and you don't have to manage the servers in the background, because there are servers despite the name, doesn't mean that it's the right thing to do for your company or for your budget. We have as an example, we have a service at work which, when people, we have multiple systems, and when someone views someone's personal information, an event is written to a queue saying who read the information, what system, what screen they were using. There is a service that reads that off the queue, denormalizes a bit, puts it in the right structure, stores it somewhere, and a separate service which you can query to get a report. So when an end user goes, hey, I want to know who looked at my data, we just look at the report. Now this is currently sitting on top of an EC2 instance. It's got two services written in it, and then we have an EC2 instance for dev, test, QA, and production. For various contractual reasons, we have a overhead cost for each EC2 machine we have. So add an extra 30 euros for each EC2 machine per month, and we now have a suddenly fairly expensive system. It's not doing a lot. We don't care about the uptime of it, because if the system goes down, the queue just fills up. When it comes back up, it reads off the queue fairly quickly. So we're paying, what, 120-ish euros a month for a system that we don't care about uptime. You get 1 million free Lambdas per month execution time. Every month, for forever. It's not just part of the free tier of Amazon. That keeps going. So as long as we get less than 1 million requests in total over our dev, test, QA, and production, it's completely free to have it in Lambda. So why don't we put it in Lambda? Mostly down to time, and it's not that important at the moment. When we want to save cost, or a developer has spare time between projects, then sure, we will probably switch that to use Lambda. But if we were starting from the beginning and had Lambda available at the time, we would have been able to look at it and go, well, on average, we're looking at about 1,000 personal item views per environment a month. Per production environment. Development environment, maybe 2 events. So there is a huge cost saving to using serverless there. But maybe for your application, you're having 10 billion hits a day to your API. Maybe having API gateway, which costs you per request. Maybe that's not the right way of storing it. So you really do have to look at your use cases. And finally, the code for this will be soon on GitHub. Depends how awake I am for the rest of the week. And yeah, feel free to check it out. Send pull requests to fix all of my horrible mistakes. If anyone can write UIs better than I can, which I suspect is all of you, great. Improve it, but I wouldn't necessarily use it as a production application, just use IRC. And finally, any questions? No, you're all... Oh, there is one. Sorry, there's a bright light.
So what is the latency from receiving a request on the API till it gets out to your projections and out available through S3? How long does that take? And did SNS and the queues and other things make a big difference or not?
Right, so the question is, what's the latency between receiving a request and it getting through the queues, projections and such, and into S3? It varies. SQS is not the most consistent of latencies. It's usually fairly low within... If there's nothing else in the queue, a message gets through within 10 milliseconds, 10 to 50. If there's a lot in the queue, obviously you end up with more and more latency. So at that point, you need to start thinking of a different way of doing it. Or in my case, I fake the result on the UI. So a user types something in the chat box and says, "Hi, how are you?" Hits enter. I put that on screen instantly, send the request out. So I am trying to make a nice responsive UI, but there is the latency cost there. The latency between the UI and AWS seems to be more of a factor than within AWS itself. So if you've got a fairly slow internet connection, then that'll be more of a problem. But it'll vary based on your message size as well. So yeah, measure it and architect around it. That's a bit of a washout answer, but it's the best I can do, I'm afraid. Anyone else? Sorry, again, light. Nope. Okay. Well, thank you very much for coming, and hope you enjoy the rest of the conference.